Hello everyone. Today our topic is the backtesting on specific investment strategies. First, I will introduce myself, and then each of my team members will introduce themselves. So let me get started. My name is Shuyang Liu.
I'm Ziyu.
My name is Liang Huang.
Okay, first let me introduce our objectives. Nowadays, some investors are highly risk averse. They are not willing to bear high risks in order to get high return. So we choose minimum variance portfolios and contingency portfolios in the project to meet the expectation of these risk-averse investors. We want to find out whether these investing strategies make our portfolio outperform the market. So we download the data from Yahoo Finance and get the results of the weights using R. Then we backtest the new weighted portfolios on Quantopian. Next, I will tell the detailed information about our design process. First, let me introduce Efficient Frontier. Efficient Frontier is the best optimal portfolios that offers the highest expected return for a dividend level, for a defined level of risk, or the lowest risk for a given level of expected return. Next, we will talk about the minimum variance portfolio. A minimum variance portfolio indicates a very diversified portfolio that consists of individually risky assets which are hedged when traded together, resulting in the lowest possible risk level of a rate of expected return. The global minimum variance portfolio is located on the leftmost point on the efficient frontier, and it has the lowest risk among all differently weighted portfolios. Next, let me introduce contingency portfolio. Contingency portfolio is the portfolio that maximum the Sharpe ratio, which is the average return minus the risk-free return divided by the standard deviation of return on an asset. We can see the graph. From the graph, we know that a contingency portfolio lies on the tangent point of capital market line and an efficient frontier. It makes the portfolio have a largest value of Sharpe ratio, which means that the portfolio has the best risk-adjusted performance. Next, Zoe will talking about our operating results.
We selected 12 stocks to make an investment portfolio. First, we read the data by R and then extract the weekly price to calculate the weekly return. Then we can get return covariance metrics. To solve this optimization problem with the constraint minimize variance and the sum weight equals 1, we get the invariance portfolio weight. Next, we plot the result and get the graph of efficient frontier. Then we calculate the optimized weight of tangency portfolio. In the last, we plot the capital market line and the GMV point. Then we will put our portfolio into Quantopian to do the back test. So now let's welcome my mate Liang Huang to show our result.
So from the code R above, we can get the weights of the minimum variance portfolio and the tangency portfolio. And we put these weights into the Quantopia, and then we do the back testing. And for here, we use the market portfolio SP500 as our benchmark. And from this graph, we can find that the average return of the minimal variance portfolio is higher than the benchmark. And where it comes to the volatility, the result is 0.14, which means that the portfolio is very stable and at low risk. And from the result of tangency portfolio, we can see that the average return of the tangency portfolio is much higher than our benchmark. And the return line of the tangency portfolio is always above the benchmark. And the risk is low because the volatility is only 0.50. So Until now, we can make a conclusion that we assign the weights to the stocks we choose. We also run the back testing by comparing the return of the market and the weighted portfolio. And in this case, we can know that the strategy is useful in the real world. That's our presentation. Thank you very much.